Okay, so before we look at our calendar and before we look at the new stuff, I just wanted to spend a couple of minutes at the start of class today looking at number 20, which is one of the problems from the questions of the day. So if it's already in the folder and you want to take it out to look at it, then you can. And if you feel like making any changes, then go ahead and write on the paper before it goes back on the folder. Just to remind you, we have a weighted voting system with 4 players. And here is a complete list of all of the winning coalitions. How many winning coalitions are there? We have 4 winning coalitions. And what we want to do is find the critical players. And it's quite strange to think about finding critical players when there's no quota and there are no weights. But it turns out we can still do it. So here's the idea. I'm going to look at P1. No, let me not look at P1. I'm going to look at P4 in that coalition right there. And I'm going to ask myself if P4 is critical. And the way you decide if P4 is critical is to temporarily cross them off. And then you look at what's left. And the question is what's left still enough to win? P1, P2 by themselves. Is P1, P2 a winning coalition? The answer is yes, because it's listed right there. It's listed separately. P1 and P2 by themselves win. They have enough power to win. Without knowing what their powers are and without knowing what the quota is, I can still say, without P4, no problem. P1, P2 is a winning coalition because it's listed there separately. So is P4 critical in that spot? And the answer is no. We didn't need them in order to win. Are there questions on that? Yeah, Alex. That they are in order, generally P1, P2, P3 in order, but that's not what's making this work. What's making this work is that if I cross off P4 and I look at what's left, P1, P2 is a winning coalition by themselves, which means P4 was not all that important in that coalition. So P4 is not critical. But let's contrast that with, say, crossing off P1 in this coalition. What's left is P2, P4. Is P2, P4 a winning coalition earlier in this list? No. So is P1 critical to that coalition's success? Yes, because if we lose P1, we end up losing. So let's go ahead and start circling critical players. If I kind of get rid of P1 in this very first one, is P2 by themselves a winning coalition? No. So P1 is critical. In fact, there's no single person winning coalition, so if you lose P2, then we lose again. So P2 is critical. What if I think about P1 in this next one? Is P2, P3 already here? No. So P1 is critical. They're really important there. What if we lose P2? Is P1, P3 winning? No. So P2 is critical. What if we lose P3? Is P1, P2 winning? Yes. So is P3 critical? No. We could do without them. And then we've already decided that P1 is critical here. P2, it turns out, is critical. P4 we don't really need. And in this next example, I think we'll again find out that P1 and P2 are critical, but we could do without P3 and P4. I'll just look at one of them real quick. If I were to lose P4, what's left is P1, 2, and 3. Is P1, 2, 3 already there? Yes, so we don't need P4. We win anyway. So P4 is not critical. So circled is all of the critical players. And we did it without any quotas and without any weights, just by thinking of that kind of shortcut way we did stuff last class. Is there a question, Mary? Okay. And then, so that's part A. And then part B is the power distribution. And so this is where we just have to count how many times each player is critical. How many times is P1 circled? 4 times. How many times is P2 circled? Also 4. P3, 0. P4, 0. And then we have to divide. Don't forget that we're looking for a fraction, which is like a percentage. And we divide by the total number of times that anybody was critical. How many times was everybody circled up there? It's a total of 8. Another way to think of it is 4 plus 4 plus 0 plus 0. So altogether, there are 8 players that are critical, counting repeats. And so that's the total amount of power we have to divvy up. And so it turns out that P1 has 50% of the power. P2 has the other 50% of the power. P3 and P4 have 0% of the power. And there's an unfortunate word that we use to describe people that have 0% of the power. We call them dummies. So P3 and P4 are dummies. That's what we're stuck with. I don't think it's supposed to be like about a mental state. I think it's about like a ventriloquist dummy, you know, like it's just sitting there but doesn't really have any, doesn't do anything. It just does what it's told, you know. All right, questions on this one? Okay, so can you guys open to page 9 in the packet? And while we're opening to page 9, we'll take a quick look at our calendar. Last class, we introduced weighted voting, and we talked about how to measure power by this thing called the Bonzoff Power Index. And today we talk about a different way to measure power. Same idea with the weighted voting systems, but just a different way to calculate those fractions. And at the end of this class, it's the last time that we will use the word voting until we review for the second test. So we're really going to deviate from all this voting stuff once we're done today. The next few classes, it's like about 4 classes in a row, all kind of about statistics and studies, and then that leads nicely into counting stuff. So we're really going to change gears after today. All right. Okay, one thing before we jump in here and before I forget, so technically the project plans were supposed to be due today, but then the snow day pushed everything back. But I think that I was encouraging people to maybe try to get the project plans in today just so we have a chance to look at them before spring break. But I realized that I won't look at them until I take these folders home with me. So if you have a project plan that's in the folder right now, can you take it out? Just put it on the table, and at some point when you guys are doing some group work, I will walk around and maybe just give you some like instant feedback about the plan so that you have something to go off of over spring break. All right, so if you have a project plan in there, just take it out. I'll look at them in a little bit. All right, so that is that. All right, so let's go to number 9, or page 9, and we'll go to number 1. Maggie? Wadada, number 2. Okay, so different way to measure power. Can we get the 3 people sitting at this table to come on up? And you can just stand up there in a line. Okay, super. And we're going to say you have 3 votes. Can you just the whole time hold up the number 3? You have 2. You have 1 vote. So the whole time, this is how many votes these guys have. And so what we're going to do is we're going to
go like that. That's actually 6. This is 3.
3. In American Sign Language, this is 3.
Show me again.
3. Super.
Clear, but you don't have 6, 2, and 1.
Okay, thank you. All right. Okay, so here's what we're going to do. We're not going to think about finding the winning coalitions and then finding the critical players, which is what we did all last class. We're going to do something different. We're going to assume that we've got this thing to vote on, you know, should we have an ice cream party at the end of the semester? It's a yes or no question, and these guys have to decide yes or no. Now, clearly, what's the answer to this question? It's clearly a yes. So let us assume going into this that they're all going to vote yes. So it's going to pass because we need 5 votes, and altogether they have 6 up there. So it's going to pass, right? But we're gonna think about a different way to measure who's important in every coalition. So what we're gonna do is we're gonna think about ordering these folks up here. We're gonna assume that they're gonna put their ballots. They each are holding up the number of votes that they have, and we imagine like a fishbowl that they're each gonna put their yes vote into. And we're just going to let them go up in different orders. So here's one order, reading left to right from your perspective. Okay, so Jason walks in there. He puts his one vote into the fishbowl. It says yes on it. We need 5 in order to pass. Is that enough to pass? No. Okay, so now we've already got one vote in the bowl. Mary walks over and puts her 2 votes in the bowl. Is that enough to make it pass? Now we now have 3, which is still not enough. And then finally, Linda walks in, puts her 3 more. How many are in the bowl now? 6. And is that enough to pass? Yes. Who is the most important person here? Who is the person that made it go from losing to winning? It was Linda, right? Linda was the person that made it go from losing to winning. So in some sense, in this order, Linda was the pivotal player. And maybe you guys did a little reading about pivotal player. And so what I'm imagining, like the word pivot, I imagine like a seesaw, a teeter-totter over the playground. And so sitting on one end is a weight of 5 pounds. And each of these guys is holding a 1 pound yes vote in their hands, several of them sometimes. And so Jason put his 1 pound on the end of the seesaw, and the 5 pounds was on the ground, and Jason put his 1 pound up here. Was that enough to pivot it? Not by himself, right? And then we put 2 more pounds. Still 5 on the ground. Now we have a total of 3 up here. Does that pivot it? No. But then finally Linda comes on, puts her 3 more. What's the total now? 6. Is that enough to pivot this seesaw to get that 5 pound weight off the ground? Yes. And so that's why we call her the pivotal player, or at least that's what I'm imagining when I hear that word pivotal player. I'm imagining who's the person that gets this thing to change, okay? All right, so we're gonna keep track of how many times each person was pivotal. Wadada, can you go on that sideboard there and just write down the 3 names? We've got Jason, Mary, and Linda. And Linda was pivotal the very first time. So Jason, nice and big for everybody. Okay, so while she's writing that, we're going to change the order. Can I ask the 2 ladies to swap places? And still reading from left to right, they're going to put their names in the fishbowl. Oh, you're on crutches. I'm sorry, I didn't see you were on crutches. Zach, can you relieve her? Thank you. Sorry about that. Okay, so we've got Mary and Linda. All right, so in this order, which is a different order, and again, we're assuming they all say yes anyway, so it's really just a matter of who is the person that gets this thing to become a winning motion. Okay, Jason by himself, is that enough? That's a total of 1. Now we throw 3 more votes on. Is that enough? The goal is to get to 5. Justin understands it's a no. Does everybody else understand it's a no? Okay, and then finally Mary puts her 2 votes on. Now how many are on the pile? Now we have 6. Is that enough? Yes, Mary was pivotal in that case. So give Mary 1 and get rid of the Y at the end of Linda's name, and we'll give her 1. Thank you. Okay, so right now we have Mary pivotal once, Linda pivotal once. Who's kind of getting shortchanged here? Like why, I understand Jason got shortchanged because I only gave him 1 vote to start, but why is he really getting shortchanged so far? He keeps starting off. Right? Like there's no way for him to be pivotal if he's going first unless he's a dictator, right? So what should we do? Well, we should change the order again. And in fact, what's the fair way to do this? We should do all the possible orders of these 3 people. Does that make sense? Then everybody gets to be in every position and everybody has sort of like, it's like as fair as we can make it. Let's look at all possible orders, okay? All right, can you 2 swap? Okay, so I'm just going to stand behind you guys. Don't worry about me. How many votes do we have now with this first person going in? We have 3. Is that enough? No. Then the second person. How many votes do we have total? 4. Is that enough? No. Then the third person. How many total? 6. Is that enough? Yes. Give Mary another pivotal victory. That's good. Okay, you 2 swap. Again, first person goes in. How many votes? 3. Is that enough? Nope. And we'll throw on these 2. How many is that? That's 5. Is that enough? Yes. Well done. Mary got another. And poor Jason, he didn't get to vote because the thing was already determined, right? The 2 women up here said, yeah, we're going to have the ice cream party. And it didn't even matter that Jason was waiting to put his vote in the bowl. It was already done. Okay, now we can swap here. Okay, first vote. How many? 2. Is that enough? Nope. Second one? 5. Is that enough? Yes. Give Linda another one. Sorry, Jason. Okay, and then finally, you two. So finally, you two swap. Okay, how many total with the first person? 2, and then another 3. That's still not enough. And then finally, 6. Give Linda one more pivotal count. Thank you. You guys can have a seat. All right, so thinking about power, somehow Jason was pivotal exactly 0 times, Mary was pivotal 3 times, Linda was pivotal 3 times. That's already a little bit of a surprise because it felt like the person with 3 votes should be stronger than the person with 2, but they were both pivotal exactly the same number of times. So they have the same amount of power. What percent of power do each of the women have? 50%. What percent of power did the guy have? 0. It still adds up to 100, and you guys intuitively are already doing the right thing. What do we take these 3's and divide them by to get our 50%? We divide by 6, because there were 6 different pivotal people up there, just like we divide by the number of critical players last class. Okay, thank you, Zach. So ultimately, I'm just going to copy the kind of final results here. So what did we do here? We said this was Linda, and this was Mary, and this was Jason. And ultimately, in terms of the power, Linda, Mary, and Jason, Linda and Mary were pivotal 3 times. Jason was pivotal 0 times. And then what do we divide by? 6. Adding up the 3, 3, and the 0, we divide by 6. And so 50% for Linda, 50% for Mary, 0% for Jason. Questions on this calculation? Okay, what we just did has a name. Last class, the name was the Banzhaf Power Index, named after a guy. This, I think, is named after 2 different people, the Shapley-Shubik Power Index. And it's exactly what we just did. Okay, so a little bit of the details here. We did all the calculation stuff. Now let's talk about some of the words and symbols. So we'll go to number 3. It says we use that to represent a sequential coalition to distinguish it from the unordered coalition, this. The only difference in those 2 things are the symbols that bracket the players. So we've been using these symbols on the right-hand side and maybe not even paying attention to it. And when we do that, we don't care about the order. We're not putting different orders on. We're just saying, here are 3 people that are voting together, unordered. But if I decide that the order makes a difference and we want to be able to swap all these things, then you got to put the kind of diagonal brackets on it. And so this is saying first P1 goes in and says yes, and then P2 goes in and says yes, and then finally P3 goes in and says yes. And there are a lot of different orders of 3 players. In fact, how many different orders were there up here? There were 6. You can see the evidence up on the board still. Right? There were 6 different ways that we ordered these 3 people. Okay, so what if we had more people? What if we had n players? Anybody know? There's a nice little formula to tell you how many different ways there are to order n people. Number of players times 2 is a very reasonable guess because how many players did we have in our example? 3, and if you times it by 2, you get 6, which is the right answer. So Alex has a formula that works for this case.
I don't know the name, but it's like panic.
Mandata says n exclamation point n factorial. We have used this, we've seen that this semester, haven't we? I'm almost certain we've seen that this semester. True? We've seen the n exclamation point. I forget what it was. We were counting, it was the number of ways to order, no, what was it?
Yeah, how many,
oh, it was how many head-to-heads.
Right, so it would be n times n minus 1 divided by 2.
Yeah, we were doing something with how many head-to-heads. If you have like 20 people and you need to do pairwise comparisons, everybody versus everybody, that involved a factorial. I think that's what we did. Okay, here's the factorial again, and I will remind you of what it means. If you see 3 with an exclamation point, it means 3 times 2 times 1. You start with your number, you keep multiplying all the way down until you get to 1, and then you stop. How much is 3 times 2 times 1? 6, which is exactly the 6 ways that we ordered these folks up here. So Alex found a good formula that happens to work in this case. It's not going to work in every case, so I'm going to get rid of that and go with n factorial. So for example, if you had 4 people and you wanted to order those 4 people in all the different possible orderings, turns out there's 4 factorial ways to do it. 4 times 3 times 2 times 1. 24 different orders for 4 people. And if you want to see those orders, which I know you do, then just look at the bottom of the page. How many players in each of these coalitions? 4 players. And one ordering is 1, 2, 3, 4 in that order. Another one, 1, 2, 4, 3 in that order. Another one, 1, 3, 2, 4. How many different orderings altogether? There's 24. You can see all 24 of them listed here. And the easy way to calculate that is the 4 factorial. All right, so number 5 is the method that we just did our example with these 3 people of. We're not going to read it. We did it. I feel like we got a pretty good handle on it. We want to do another one, but I feel like we understood the calculations as we were doing them. But we will go to number 6 for Zach. Okay, so again, I want to show you what you're going to be bringing with you. This is page 2 on the test, and it is a description of exactly what you do to try to find who the pivotal player is and looking at all the different orders. And here's a list of the 6 ways you can order 3 people. We just did that with Jason, Mary, and Linda up here. And down below are a few copies of the 24 ways to order 4 people. And so we're going to see how to use that right now as we do another example. So let's try number 7. We go to Holly. Okay, so suppose that we're looking at these 4 people. So we've got P1, P2, P3, and P4. Okay, and the goal here is to find who the pivotal player is in every coalition. Again, we're assuming that everybody is going to say, yes, I am in favor of the ice cream party. So this thing will pass at some point, no matter what order we put them in the fishbowl. It's really just a matter of who is the person that makes it pass. Okay, I'm going to do this one way, and then I'm going to show you the way that I think is better. How many votes does P1 have? 4. Is that enough votes? The quota is 5. Nope. How many votes does P2 then throw onto the pile? 2. How many do we have now? 6. Is that enough? Yes. P2 is the pivotal player. No need to keep going. The motion is already passed. P3 and P4 would be irrelevant at that point. This is one way to do it. For me, here's what I prefer to do. It takes a little bit of time in the beginning, but I'm going to find all of the P1s. How many votes did P1 have? 4. What I would do is write a little 4 right above every single P1. I know it's tedious, I know it's annoying, but for me, this is actually a good use of time because then it makes the rest of the calculations really quick and really accurate, as opposed to continually having to look back up at the top. How many votes did that person have? How many did that person have? I'm just going to put them all on there. And so give it a shot. Put all the different 4s on, and then put all the 2s on, and then 1s. And then see if you can't go through all 24 coalitions and circle the pivotal player. And work with your neighbors. Don't move on to the second column until you guys have all checked with each other that you agree on the first column. Okay, how many times was P1 pivotal? A lot. 18 is what I saw. How many times was P2 pivotal? Only twice. P3? Only twice. P4? Twice. Now, as you can see, there are a lot of details in order to get this calculation right. I don't think any of the details are hard. There's just a lot of them. So be really, really careful as you're putting your numbers, your weights up on the top, and then be really careful as you decide which is the one that's pivotal in every single row. As a quick check, what do you get when you add up those numbers in blue? You get 24. If it's anything other than 24, you made a mistake somewhere. Even if it's 24, you still might have made a mistake somewhere, but at least make sure it adds up to 24. And 24 is the magic number that we should divide by in this case. So can somebody with a calculator tell me, let's see, so 18/24, that's easy, right? That's 75%. What is 2/24? Okay, 8.3%. And so this is the distribution of power here. Questions on that? Yes. Yeah, the squiggly things. Can anybody help us out here? Roughly equal to or approximately equal to. Yeah, yeah. Okay, so that is good, good, good. So we have a few more things to do today, but this seems like a good time for you guys to start voting again. So if you came up and handed me ballots, can you come get them right now and just distribute them? So we have a total of 4 polls that you guys are going to participate in. Oh, that's not yours? Oh, I'm sorry.
They're all just the different sizes.
That's yours. This is Jason. Okay, so distribute, and if you guys can vote and make, could you make separate piles for each poll? Keep the polls separate. Okay, so we'll go ahead and start back up again. We'll take a look at number 8. So number 8 is about finding the bonds-off power index, the BPI. This is different. This is the thing we did last class. So we're not thinking of pivotal players. We're not thinking about ordering everybody. We're just going to find the winning coalitions. So we're going to list, are there any single winning coalitions, a player by themselves that has enough votes to win? No. No dictators. Now we're going to look at the pairs or the duos. So let's start listing the pairs of players that can win. We need 5 or more. So P1 with P2, that's enough. Okay, P1 with anything, that's a nice shortcut. What about P2 with P3? No, so we don't need to list it. We're only listing the winning coalitions. So we're not going to list P1 with P2 with P3. Any other duos that are not listed that win? The answer is no. You can run through them. Again, remember on the first page of the packet, you do have a list of all the different possible coalitions with 4 people. Here they are. So we just listed these 3. There are 3 other pairs we did not list, but with this in front of you, there's no reason to miss anything. So you can just check them one at a time, and I think you'll see that none of those other ones win. So now we'll look at the trios. Trios. We'll list all the trios here, and then we're going to erase anything that doesn't make sense. I'm going to list them in the same order that they're listed on the on that first page of the packet. Again, having that handy is a good suggestion. P1, P3, and P4. P2, P3, P4. So look at them one at a time. You don't need to write them all down. You only write the ones that are winning. P1, P2, P3. Is that winning? It is. P1, P2, P4. Yeah. P1, P3, P4. Yeah, and we can kind of use Zach's nice shortcut here. P1 with anybody, right? P1 has almost enough votes to pass. So if you throw anybody in the mix with P1, they'll win. All right, how about P2, P3, and P4 without P1? Is that winning? If you add up the last 3 votes here, 2 plus 1 plus 1, not enough. We don't list them. What's the only other winning coalition that's not here yet? It's the quad. Everybody. And then we go back and we find the critical players. And this was difficult on Tuesday. It's going to be even more difficult because now today we have this new concept of pivotal players. And it's really, really easy to get them mixed up in your mind. A critical player is somebody from a winning coalition that if you remove them, it becomes a losing coalition. They are critical to the success of that coalition. If you remove P1, is P2 by himself enough to pass this motion? No. So P1 was really important. P1 was critical. What if you remove P2? P1 does not win. That makes P2 critical. Can you guys, with your neighbors, go through, circle critical players, do not circle not critical players, and check with your neighbors. So I think I have done this right, but can you check me? Have I circled all the critical players? So in the pairs, everybody's critical, but in every other place, only P1 is critical. And again, it comes back to what Zach had said. P1 with anybody will win, which means if you take out P1, you're going to lose. And if you take anybody else out, as long as there's other people there with P1, then it's fine. Okay, so then don't forget, after you circle everybody, you also have to count the power. So P1, P2, P3, and P4. How many times was P1 critical? 7 times. P2, only once. P3, only once. And P4, only once. Don't forget to divide. Every time I teach this class, I give a question like this on the test, and every time people forget to divide. They stop at 7, 1, 1, and 1. 7 doesn't mean anything. Percentages mean something. This is 7 out of some number. There's no fancy formula we're looking for to figure out what to divide by. You just have to divide by the sum of all the numbers that you see in purple. How many numbers do we see in purple there? It's 10. The same as the number of times somebody was circled. There were 10 times that somebody was critical. 7 out of those 10 times, it was P1. Great, now we're talking. I have something to compare. 1 out of how many? 1 out of 10. That gives me a sense of how important P2 is. And so in terms of percentages, these ones are easy. 70% of the power is for P1, and each of the other players has only 10%. Questions on that? Justin. That's the critical player, yes. Everything you just said is perfect for the critical player. Yeah, the pivotal player is this thing where you assume everybody's in favor. The only question is, if you put them in order, who's the one that tips the scales? Who pivots it from being losing to winning? It's really, really easy right now for these two ideas to be jumbled because probably Tuesday's idea wasn't clear, like it still hadn't had time to settle in yet. So now we throw another one in there that's similar but different just to really confuse you. Okay, one thing we can do is compare. This was our answer using the Banzhaf power index, 70, 10, 10, and 10. Did we get the same numbers doing it the Shapley-Shubik way? It's close, but not the same. 75%, 8.3, 8.3, 8.3. So you get numbers that are similar, but different. It really is a different way to calculate power. Which way is better? I don't know. I mean, just know that you get different answers. Same way when we had different ways to count the votes, you could get different answers. Okay, so that is that. Another thing I'd like to take a quick look at is number 9. Who's our reader now? Holly, did you read?
Yep.
You did. Emma? Okay, so this is our first time kind of like making up a weighted voting system where the number, we're not given numbers, we're given like something we have to kind of piece through. So first of all, how many players are in this example? 4? 5. 5, right? 4 advisors and the king. These are the people who are going to vote yes or no to the ice cream party in the king's courthouse. Okay, so we got 5 people. Okay, so we're going to list 5 different things in here. And the question is, what number should we put? Well, I don't know. We just have to make stuff up. It doesn't say how many votes each person has. So this is something we kind of piece through. So here's my method. There are other methods, and there are a lot of right answers to this question. But what I like to do is maybe start with the weakest player I can find and give them 1 vote. And if it turns out things come to some contradiction later on, then I'll change it and make them 2 votes. But I just start with a 1. Now, what can you tell me about the advisors here? Different power or all equal power to each other? Feels equal, because it doesn't say anything, any advisor is special. It just says 4 advisors. The king can be overruled if all 4 say the same thing. So if they're all equal, then how many am I putting for each of them? Feels like we're putting a lot of 1s. Okay, so now I'm actually ready to make up a number for the quota. If all 4 of the advisors are together, the thing passes. Right? Whether the king is in favor or not doesn't matter. If the 4 advisors agree, they can do whatever they want. What number is the quota? Can you hold up, instead of saying out loud, can you hold up the number of fingers that you think is a good quota to make it so these 4 advisors can pass something by themselves? Good. And we see lots of 4s. 4 is the right number because that is the sum of the 4 single votes that we are looking at. So at the moment, the 4 advisors can pass things if they all vote together. And the last piece of this puzzle for me is to figure out how many votes should we give the king. I've got 1 vote for 3. What did you say? Another vote for 3. Let's start by giving the king 1. And let's just see if, you don't need to write it, but let's just see what happens. I said sometimes you get a contradiction and then you have to change things. The sentence up above said that if the king could get 1 of his advisors on board, then he would pass the thing, right? The only way for the king not to pass is if all 4 advisors are against. So if the king has even 1 advisor with him, then the king passes the thing. So if the king has 1 advisor with him, how many votes do they have at this moment? 2. Is that enough? No. So you can see I didn't give the king enough weight. The king has to have more in order to reach that quota. So, whoopsies. That was a little bit too massive. So let's change the king to a 2. If the king grabs 1 of his advisees, still not enough. So let's change it to a 3. If the king has 1 of his advisors, is that enough to pass? It's 4. It's enough. And we have found a system that describes the sentence up above. Now, I started giving the advisors 1 each. You could just as well have started by giving them each 2. You'd come up with a different number for the king, a different quota, and a different acceptable answer. There are a lot of right answers to this problem. I start someplace with 1s, and if I need to change stuff, then I do. Questions on that? Okay. How many players were in this example? 5. If I wanted to think about this shapely Shubik thing with all the different orderings, how many different orderings are there with 5 people? It's 5 factorial. 5 times 4 times 3 times 2 times 1. 120. Can you imagine? You guys are kind of annoyed even doing the 24 that I asked you to do at the bottom here. Can you imagine having 120 things where you have to list all the numbers like we did, and then you have to look at every single row and find the pivotal player 120 times? Kind of annoying, right? Okay, but there's not a whole lot of thought that goes into it once you understand the process. And computers are really good at doing processes when there's not a lot of thought involved. So there is a web page that you have the link to. It is right there. I will show you this web page now. And all we need to do is add some rows. So first thing I'm going to do is make something with 4 people, not the king example, but the one before. What was the quota for the example that we did at the top of the page? It's 5. And so that's fine. And then what was the weight of the first player? It's 4, and then the next one, 2, and then 1, and then 1. Okay, right now we're in the Bonzoff index tab. You can see the Shapely Shubik is the other tab. If I hit compute, so don't blink, you'll miss it. 3, 2, 1. Is that what we got? 7 out of 10, 1 out of 10, 1 out of 10, 1 out of 10. Okay. You probably did miss this one because it did it even though I didn't ask for it. So there's the other one. Did we get 18 out of 24 and then 2 and then 2 and then 2? And you can see the percentages here. Well, it's real small, but it says 75% and 8.3%. So it does it. It does it in no time flat. Let's take a look at this king example. I need to add one more row. What did we say for the quota? 4 was the quota, and the king we gave 3, and then everybody was 1. Okay, let's compute there. All right, I don't know if you can read it in the back, but it says the king has 60% of the power, and each of the advisors has 10% of the power. 60, 10, 10, 10, 10. Okay, is that fair? I don't know, it's up to the people, it's up to somebody to decide, but at least I have a very real sense. How strong is the king? 60% of the power is the king. That's in the Shapely Shubik. If we go to Bonzoff, it's a little different. It's about 64% for the king compared to 9% for each of the advisors. And another really nice thing about this is it has some examples already programmed in. What was the leading example we talked about on Tuesday? It was the Electoral College. We spent lots of time thinking about the Electoral College as a weighted voting system. Okay, it's true. States do not have to vote Republican or Democrat. There could be more than 2 choices. There will be an abundance of choices on the ballot, but it has been hundreds of years since a state has not gone Republican or Democrat. So let's just assume it is a 2-choice thing. It is a yes/no thing. And we wanted to know how powerful is California with 55 votes compared to Massachusetts with 11. Let's take a look. If you go to this drop-down menu, you can see here it says Electoral College 1990, Electoral College 2000. The numbers are already typed in there. I don't think I can make this any bigger. Oh, I can. Wonderful. Is there any chance to read that in the back? Okay. Okay, so you can see California is up there with 55. Let's find us. I think we had 12. There we are, number 13 in the nation. This is before the 2010 census. So it's been, like, we've dropped down to 11 now. And so can you imagine thinking about all the different winning coalitions with the 50 states? Remember the goal for the to win the presidency, you need to have at least 270 of these votes, these electoral college votes. Can you imagine all the different ways that states can get together and say, for example, we're going to vote Democrat, and we just need a total of 270 of those votes for the Democratic candidate to win. So maybe the first, I don't know how many, like the first 20 states here, maybe that's enough. Or maybe we throw Minnesota out and we bring Colorado in. And then we throw Colorado out and we bring Louisiana in. Do you see how mind-numbingly large this number of coalitions is? All the different ways states can say, we're going to vote Democrat and we just need to get 270 or more. There's a lot of ways. And then going in the other side, the Shapely Shubik thing where we do all the orders. We have 3 wonderful volunteers here. How many orders with 3 people? 6. With 4 people, how many orders were there? There were 24. With 5 people, we didn't even bother doing it. How many? There were 120. With 50 people, can you imagine how massive the number of orderings of 50 people is? 50 states. No, it's 50 times 49 times 48 times 47, all the way down to 1. It's an enormous number. Okay, let's give this a shot. So I'm going to make this a little bit smaller here. somehow we just lost the states and went to the, what did we go to? Is that the UN Security Council there? All right, let's go back to the states. Okay, so here are all my states, and we are going to compute. How long is it going to take? It's got to do, it has to do all the orders. We had 6 orders up here. It has to do all the orders with 50 people, 50 states. Half an hour, a minute, half a second. Okay, let's try. 3, 2, 1. Half a second's an exaggeration. It didn't take half a second, right? Okay, and not only did it do those, but it also behind the scenes did. Oh, it didn't do that. I guess it's slacking. Okay, there's the rest of the numbers. Okay, so what do we see here? So according to the Shapley-Shubik, California has about 11% of the power. I can understand that. I can't understand 55 votes out of 270 looking at all the possibilities for California to be part of a winning coalition, or for California to be the pivotal player if we're thinking about orders. I can understand 11%. California has 11% of the power when it comes time to elect our president. Great. Is that good or bad? I don't know. You can decide. But at least we have a sense. We have something that we can put meaning on. Texas is number 2 with about 6.5% of the power. New York has about 6% of the power. And then you can go down the line. Florida is oftentimes really, really important in an election. I would argue maybe more important than the top 3. Technically, Florida has only 5% of the power. Why am I saying that in reality, Florida has more power than any of these 3 stronger states? This is not a math thing. This is like a political science thing. They are a swing state. What does that mean? It could go either way. Historically, Florida sometimes votes Republican and sometimes votes Democrat. Historically, what does California do? Democrat. Historically, what is Texas? Republican. Historically, what is New York? Aren't they Democratic now? Historically. I'm not saying every election. Florida is really the first one, which is kind of like up in the air. Florida was really important back in 2000 when Bush and Gore were like neck and neck, and it came down to Florida. It was so close. And so this does give us a sense of like absolute power, but you also have to think about historical trends. You know, let's be honest. We're going to vote for the Democratic candidate come November. It's what we've done for 150 years, 200 years, I don't know, long time. But you can see the distributions of power here, and technically we have about 2.2% of the power, although I think we're now down there because we lost an electoral vote, so now we have about 2% of the power. Questions on that? Okay, so what I'd like to do to kind of finish today is go here. And let's just talk a little bit more about the projects. So you can see a bunch of folks have chosen the conduct your own election method, and that's fine. And I know that some folks maybe haven't quite made any headway on this yet, so I just want to encourage you to start thinking about them soon. The deadline for the first project is April the 5th. That will be here before you know it once we come back from spring break. I do accept projects up to 1 week late. Up to 1 week? No, I think more than 1 week late. But every day that class is happening, it's 5 points off your project, even if it's a day that we don't meet. So if the projects are due on what day is that? It must be a Thursday. So if the projects are due that Thursday and you don't give it to me until Tuesday the following week, then you're 1 day late for Thursday, another day for Friday, another day for Monday. That's 3 days late. That's 15 points off. It's kind of steep. I mean, you want to get it in on time. So don't wait and lose 15 points right off the bat. All right, so that's the due date. Again, all the information on the projects is in the back of the first packet. If you don't have your copy anymore, it's up on Moodle as a Word document. You can just grab a few pages, okay? Again, we're not going to read all this stuff to each other, but if you want to know what your responsibilities are for the project, that's a good place to go. Tells you how long papers should be, tells you about the expectations, tells you how I grade it. Here are the questions I'm going to ask myself to decide if your project is sufficient. If I can say yes to all 6 of those questions, you will get an A on this project. Also recognize that you have a chance to revise the project after you hand it to me. I'll give it back to you as soon as I can, And within 1 week, if you want to address any of the comments that I made, you can change them. If you're happy with the grade, you don't need to do anything. Okay, so what I'd like to do now is talk a little bit about, well, first, do we have any questions about the projects at this moment? If you finish the project early, feel free to give it to me early, and then I'll give it back to you as soon as I'm able. So you don't need to wait until that date. If it's done, you can hand it to me. And let's talk a little bit about plagiarism. Plagiarism is oftentimes a scary word because it can be associated with some very severe penalties. Like if you plagiarize in an academic setting, you can face penalties from like a slap on the wrist to an F on the paper to an F in the course to getting expelled. Plagiarism penalties out in the real world beyond the academia can be even harsher than that. You can lose your like your credibility as a professional if you end up plagiarizing. And so we talk about it not as a not as like a negative thing. It's just a hey, here's how we can avoid these negative things. Can you guys take the plagiarism packet out? It's the If you have it with you, take it out. It's got this flow chart on the back. We'll just talk a little bit about plagiarism in our last 5 minutes today. So it says, why should you cite your sources? And I've listed 4 reasons, and I'm sure there are others, but respect, honesty, support, and protection. Respect for like if you are getting information from some outside source, then you want to respect that person's work and all the things that they did to get that information, to create that information. So you want to give respect to them. Also want to respect yourself. If you claim something as your own and it's not, I feel like you are disrespecting yourself in addition to the person you are stealing from. Honesty, we don't need to clarify. That's pretty clear what that means. Support, if you have some basic idea you're trying to convey, something you believe to be true, well, it's not enough to just say, I believe this to be true. I don't think that the UN Security Council is fairly distributing power. Okay, that's an opinion. You support it with facts. You go and you do some research and you find some folks who have done lots of stuff about analyzing the UN Security Council, and you support your idea with, yeah, and then support them as well. Thank you. And then the protection, that's against all the scary penalties that we talked about before. Again, there's lots of good information about citing your sources at the end of packet 1. I got that from the library. And key things to know in terms of avoiding plagiarism. Oh, I've got a couple of nice little flowcharts here on the back. And I know they are a very simplified way of thinking of things. That's how my mind works. I need very concrete guidelines to help me through this because it can be very tricky to, am I plagiarizing or am I not? So, do we know how to read a flowchart? So on the back page, the first question you have to ask yourself, is the stuff you are going to put in your paper somebody else's words? If the answer is yes, if you are directly quoting somebody else's stuff, you put quotations around it and you cite it. Hopefully that's clear. Again, if it's not your words, if it's somebody else's words, you put quotes around it, you cite it. It is a good thing to have quotes around something and cite it. It does not detract from your paper. Your paper is not supposed to be a completely original thing. You're trying to look at the stuff that's been done and kind of bring things together and form an opinion. There should be some of you in the paper, but there should also be some of some expert in the paper as well. So quotes and citations makes your paper stronger, offers support. Okay, suppose it is not another's words. Next question, is it another's idea? Is this an idea you created or is it an idea you found out about from somebody else? If it's somebody else's idea, you cite it. You don't need to quote it. You can interpret the idea in any way you see fit and put yourself in the paper. But if it's somebody else's idea, you cite it. If it is your idea, something you completely came up with on your own, you don't need to cite it. Donna?
Also, there's a middle ground between quoting and putting in your own. Like, you want to quote it, but want to flow more with your paper and use different kind of use graphics and the part that you changed.
Okay, good. So maybe you guys have seen some of that where you want part of a quote, but you also want to kind of put some, you want to make some slight changes. Then there's ways to do that. Good, thank you. Can you guys go to the previous page? Another flow chart. First question, did you think of it? If you thought of it, what happens in terms of citations? You don't need to cite it. So all the people that did their polls today are doing original research. They created a question, they passed it out, they're collecting data, their own data, they're going to analyze their own data. What citations do the people that conducted the polls have to use? None. It's all their own. But if you're doing a research paper, we got to really think about giving credit where credit is due. Okay, suppose you didn't think of it. Next question, is it common knowledge? I think one of the examples you guys looked at when you read through this for homework a little while back, something about, was it Abraham Lincoln who chopped down the cherry tree? Or the log cabin, Abraham Lincoln living in a log cabin. Okay, did you create the idea that Abraham Lincoln grew up in a log cabin? No. Is it common knowledge that Abraham Lincoln grew up in a log cabin? Sure. So you don't need to cite it. If it's something that is just common knowledge, you don't need to cite it. But if it is not common knowledge, if it's something more specific, more specialized, something that you kind of learned about by doing your research, you cite it. Other questions on that? Okay, so we'll call it a day there. Again, the idea is not for it to be scary, but to just be safe and protect yourself. And, oh, one last thing, hold on, wait. Have we talked about Wednesday of next week? Wednesday of next week is March 14. That is a very special day in terms of mathematics. 3/14 is Pi Day. 3/14 is Pi Day. So on Pi Day, you can have lots of pizza and cobblers, anything that's kind of round, circular. Celebrate responsibly. That's what I will say. Yeah.